So they say they found microplastics in our urinary tract. This was reported by New Delhi television. They say a new study challenges a 2019 World Health Organization report that microplastics in drinking water are harmless after confirming their presence in kidney, urine, and bladder cancer samples. Okay, so according to this new study, we have microplastics in our kidneys, our urine, and in samples of bladders that are cancerous. This is a scientific article. It's in this Journal of Exposure Science and Environmental Epidemiology. This is fairly recent, I believe it was last year. It's a review article, so they are scoping, they're looking at published literature and trying to assimilate it together and draw some conclusions. This is kind of a capsule summary of their conclusions from their literature review. 70% of kidney samples have micro and nanoplastics. That's what that MNP stands for. And you can see they even did us a favor and put a whole bunch of dots in these kidneys and all over to, kind of illustrate where we're supposed to think there's microplastics. Almost the same percent in bladders, where these are tissues from cancerous bladders, and then 54% of urine samples. Then they go on to say something about consequences like cancer and low cell viability. But before I even look at the consequences, I want to know if these findings are correct. So let's look at the literature they reviewed to come up with this picture of microplastics in our urinary tract. Here you have it. This is the extent of their review. It's 6 papers. We'll go through them one by one and see what we conclude. I know the font and text is kind of hard to read, so I'm going to call out each one and give you the basic summary. So the first one, according to the review, they found 8 microplastics in 4 of 6 urine samples. This is a reasonable particle size for being in urine, and these are the types of polymer that were observed. So they weren't too far off on this one. There are, in fact, 6 samples. 4 of them showed microplastics. There was actually 7, not 8. So they claim to have found 7 microplastic particles in 4 out of the 6 urine samples that they observed. Of course, I don't stop there. That was their claim, but I have some questions. But before I ask those questions, I want to point out that within this paper, the word preliminary was used 5 times, including the title and the abstract. So they were clearly trying to say, we have some initial data that looks like there may be microplastics in urine. We need to do some follow-up. But, if you're going to do some follow-up, you can always maybe improve your procedures and try to be more careful and more thorough. And so there's some questions that I have that hopefully they consider if they do follow up on this with a larger study. And the most important one, in my opinion, is how do you count for the microplastics that may become airborne while the volunteers are getting their clothes out of the way in order to provide this sample? Because we know that microplastics adhere to the skin, they adhere to our clothes. And so when you do that moving around, you would think that that's an opportunity for a few additional microplastics to become airborne in the presence or the neighborhood of the sampling vessel. So I don't know whether they somehow account for that with their procedural blanks. Of course, I asked them via email, and I have not gotten any reply. So that's a big question that I have, and especially when you're looking at approximately 1 microplastic per sample, it could be significant. You really have to watch absolutely everything. And of course, one thing you can do, as any plumber or engineer knows, if you want a nice clean sample, you want to purge the pipes before you get it. So, you could collect a first fraction and a second fraction for each sample, and the second sample might be cleaner. And that would be a way to look for that. Of course, it's such a small number, it's going to be difficult, but that would at least give you a chance. And if you combine that with maybe 100 samples instead of 6, you might start to get to maybe a more reliable study. Then they have a couple of basic questions that are not answered in the text. There is no supplemental. So, they don't even say how much urine was collected. So we don't know what the concentration of particles presumably is in the urine. And so that makes it difficult to compare with other studies. And then they never say how many procedural or environmental blanks they used, and they never say what was found in them. So in some ways, this is a little like the first paper in the case of the placenta, where they tell us that the blanks are sufficient, but they don't really give us the data for us to make up our own minds. Okay, so that's the first one. This is a pretty good paper. We just don't know for sure. The second one, okay, according to the review, there were, quantity listed 23 in urine, 43 in kidney samples. They don't say exactly what they mean by those numbers. And then these sizes are reasonable, and the kinds of polymers are reasonable as well. So what's actually in the paper, 23 particles were detected from 10 urine samples and 43 particles from the 10 kidney samples. Then of those 66, 26 of them were identified by MicroRaman spectroscopy. So let's see what they actually found. And if you look in the urine samples, there are 4 of those that are microplastics. Okay, so it's actually in the 10 urine samples, there are 4 microplastics that were identified. In the kidney samples, there's 1. Okay, so there's 1 microplastic particle in the 10 kidney samples and 4 in the 10 urine samples. All the rest of these are like dyes and pigments and inorganic materials. They may be important with regard to human health, but they're not microplastics. And if you're going to talk to the World Health Organization about microplastics and do a review nominally about microplastics, then you should count the microplastics and not just call every particle a microplastic when it clearly isn't. Okay, so they were way off on this. Even then, I still have additional questions for the authors. It's very similar to the previous one. And again, they don't tell us how many they found in their blanks. And in this case, they didn't even do laboratory blanks. They just did procedural blanks. So, 4 particles out of 10 samples. And this time they told us they're somewhere around 200 milliliters on average. And we're looking at 4 essentially dust particles that were made of plastic in almost 2 liters of liquid. And, any sort of background contamination is going to be relevant. It's just not a complete scientific report if this information isn't provided. Okay, let's go to the third one. This is the one about the bladder resectates. That just means pieces of bladder that came from a surgery. The surgery happened because there was bladder cancer. And according to this review, 13 of those 19 have microplastics in them. And it's polystyrene and polyphenylene sulfide is what they found. Well, okay, so here we go again. What they found was that many microparticles. Only 3 of them were actually plastic. So 2 polystyrene, 1 this polyphenylene sulfide. This is the first time I've ever seen polyphenylene sulfide as a microplastic in any study. And I looked it up, and one of the uses of that is in surgical instruments. And by the way, polystyrene is also used in surgical instruments. So that's one potential source of these microplastics that ended up in these tumorous tissues. But the main thing is, again, there's only 3 microplastic particles in all these samples. There are a lot of other particles. They may be important, but you don't say there's 13 microplastics when there's 3. And by the way, the authors are upfront about, they used a different method for characterizing the particles here. They looked, they didn't isolate these. They identified them using Raman on the tissue itself. But they say at the end, this is a quote from that paper, that further studies are needed and careful preparation protocols to minimize potential contamination. So, like, they're not being careful to avoid plastic at all. I mean, this paper isn't even about microplastics. This paper is about a new method to find particulate matter in bladder samples. And they made no effort to avoid plastic contamination in these samples. So there's really nothing here that's of relevance to this review paper. Okay, here's the next one. I want you to focus this time on the size. Okay, so these guys are finding fibers. It was never fibers in any of the other papers, and some of these are monsters. 871 microns is not something that most people would say will end up in your urinary tract. So that's a question. And then according to the review, the fragments they have are between 0.01 nanometers and 6 micrometers. Okay, that's what they say in the review. So let's see what they say in the actual paper. Okay, the fibers is exactly the same, 10 to 871 microns. So, that's something that you've got to think about, whether we really believe that that came out in the urine, or maybe that was some fibers that were in the air that somehow landed in there accidentally. But then what they say for the size of the fragments in the paper is 0.01 to 0.34 nanometers. And they say these were collected on a 0.45 micrometer filter. So, I mean, the largest one fitting 10 across would still go through this pore size. So I don't know. And by the way, a carbon-carbon bond is about 0.15 nanometers. So this isn't even big enough to be a molecule, let alone a nanoparticle. So I don't know if they're like collecting clusters of quarks, or I don't know what's going on. I think this is probably a typo or something wrong with the instrumentation, but this is just an absolutely unreasonable size range. This is a hard to believe size range for a different reason on the opposite end. But all of that maybe will be corrected when you realize that this is a preprint and it has probably not yet undergone peer review. So this is not even a peer-reviewed paper yet. It's in the process. And hopefully the peer reviewers are sharp enough to notice that some of these size ranges don't make any sense. And maybe eventually this will get cleaned up and they'll correct everything and it'll be a useful paper. But this is not even a peer-reviewed paper yet. It's not the kind of thing I would want to show to the World Health Organization to try to tell them to change their stance on the purity of drinking water, right? Okay, here's this next one. These are pretty reasonable size range, 15 particles from 7 out of 12 urine samples. They found a little different range of plastic types, but they're using fancy new methods: pyrolysis, gas chromatography, mass spec, and then laser direct infrared. Let's take a quick look. So pyrolysis, GC, mass spec, there are so many of these papers coming out now using this method, and they always claim to find microparticles and nanoparticles, so micro and nanoplastics. And so far in all of these videos, I've been avoiding nanoplastics and just focusing on microplastics. But this method is just fraught with this kind of overestimation of the amount of material found. So if you work through this, 1.5 milligrams, even if these are pretty big cubic particles, that's over 400,000 particles. Everybody else is finding, 1 and 2, or per kilogram, maybe 5 or 6. But this is like, based on the best estimates we have, this is like, 10 or 20 years of exposure via the normal exposure routes. So, this is just not reasonable numbers, but this is this kind of thing. These pyrolysis GC mass spec reports are always giving these unbelievably, and I mean unbelievably in a literal sense, unbelievably high numbers. And I know we need to talk about this method more, but it's going to take me at least one video, maybe 2 or 3, to explain what might be going on here. But the capsule summary is, I just, these numbers aren't credible. Okay, using this fancy laser IR method, 15 particles per kilogram, that's, it's a little higher than what the other studies are finding, but this is, this is a believable number. I wish I could tell you more, but I wanted to look at this article in detail, and I just couldn't quite pull the trigger on the $40 it would take to buy the PDF to look through yet another article that probably isn't doing its controls properly. I apologize. I did not read this in detail. This may be a great article, but the bottom line is, once again, we're finding some microplastics in urine that are a little bit above limit of detection or around the limit of detection. Okay, this last article, number 6, 17 fragments and 10 kidney samples, 9 and 10. Wait a minute, 26 fragments in 10 kidney urine and 10 urine samples with these polymers. That may sound familiar to you, and that's because it's exactly the same data as the second article on this list. Okay, so there's nothing new here. Okay, so let's summarize. This first one, preliminary evidence of a few microplastics in 6 samples. The second one, again, a few in 10 samples. These are urine samples. And they don't, as far as I know, they don't account for the fact that they may be coming from the skin or the clothing of volunteers. This one, they did see 3 microplastics in 19 bladder samples, but they made no efforts to keep out extraneous contamination, like, for instance, using plastic surgical equipment. So this is nothing. This is a big nothing burger with regard to this review. This one was not peer-reviewed yet. The size ranges don't make sense. This one, they find about 15 microplastics per kilogram of urine in 7 to 12 samples, so this may well be a legitimate paper. And this is the same data as above. So what we really have, in summary, is 70% kidney samples. That's pretty rich. There are no, this is just not true. Okay, so they found 1 microplastic in 10 samples. There's another paper that I went over with you with the cirrhotic liver tissues, where they stated explicitly that they don't find any microplastics in kidneys. And they showed the data that are well below the limit of detection. 1 microplastic in 10 kidneys is well below the limit of detection in any study. So this is just not, there's no microplastics in kidneys according to all the evidence we've seen so far. This is one study that wasn't looking at microplastics that absolutely does not provide any evidence of any microplastics being present in bladders, cancerous or otherwise. All they show is that they have a method where they can see microplastics in bladders, but they don't know whether they came from the bladder itself or whether they were introduced by some external agent, such as medical equipment used in a surgery. This last one is pretty much true. Okay, so about half of the urine samples that were looked at, they did see some microplastics in there. The numbers are below typical detection limits. They're close though. So I mean, this is maybe like the results that were reported in those 3 papers where they found microplastics are credible. It's just there's an alternative hypothesis for how those microplastics got into their samples that was not sufficiently addressed. So as a scientist, I have to remain skeptical. As a human being, honestly, I'm a little surprised and a little disappointed that more microplastics are not found in the urine. I mean, I certainly don't mind peeing out microplastics into the toilet so they get flushed away. Like, that just to me means that the body is doing its job properly. So I actually would have been, as a human being, I would have been more comforted by more microplastics being found in urine samples, but they're really close to the detection limits. And I want to state again, this is really, really hard. I mean, they're looking for just a tiny, tiny number of tiny, tiny particles in some significantly sized fractions. So I don't mean to say that the scientists doing this work are hacks, but I wish they would be a little more upfront and honest about how certain any of us should really be that this number isn't really zero, and it's certainly close to zero. So that's the summary that I would have. And as for, what would I tell the World Health Organization about drinking water based on this overview? This would be my message. Thanks for watching. There's more to come.